Hey Jishnu, how are you?
Are you? Hey, can you hear me?
Yes.
Yes. Yeah, I'm good. How are you?
Good, good. I see you've been going
Yes.
through the lessons in the challenge.
Yeah, I'm actually making some time to go through it.
Nice. That's good. I also saw your feedback. That's really helpful. Thank you.
Yeah, cool.
So, overall, what do you feel?
Yeah, it's actually very nice because uh, I can imagine the effort that you have put into it. That's
Mm-hmm.
really appreciated. Uh, because during the first 2 or 3 days, I felt like it was very easy, but
Mm-hmm.
now things are getting interesting as well as complex.
Nice. Okay. Well, it's going to get even more complex.
Okay.
I hope it'll be okay. I don't know. I mean, so I'm just trying to set it up in a way like the first few days it has to be simple because if not, people will drop off, right? Like that's the main thing. Um, and the I think the second week is a little bit it's not too complex. It's kind of like moderate, introducing the concepts. I think third week is when it gets a little bit more like the velocity would increase. So you'll have to see how it kind of plays out. Um, I don't want it to be completely flat because then it'll be boring and we wouldn't be able to cover a lot of things. So
Yeah.
so early on, the first week, I was like going through every detail, like, okay, this is why we are doing this. This is what it is. The second week, there will be a little bit of like, I wouldn't say jump, but a little bit of um, concepts that I would introduce, but I wouldn't be like getting into the, um, I shouldn't say details of it, but more like I expect that the reader would connect certain concepts based off what they've read. And third week might be a little bit faster. We'll see. So it's kind of like the thing with teaching is when you set up something, your lessons, and you're kind of like doing things, you would expect that, oh, this is going to be easy, this is going to be tough. But when you actually put it through the students, and it turns out that what you thought would be easy would be actually hard, and what you thought would be hard would be easy for them, right? Like depends on the perspective would be different, and so we'll have to see um, how this plays out.
Yeah, based on the complexity, it is actually nice because you place those things very intuitively, and
Hmm.
you also have a simulator. So
Hmm.
I think I'll be able to manage. Like, let's see.
Okay, cool. That's good. I mean, I kind of um, since you've already gone through some of the concepts, like you've been doing some courses and things like that, right? So I was hoping it'll be on the easier end for you. So, so I'm interested in your opinion. So if it is a little harder for you, then I guess it might be even harder for people who are just getting started. So we'll see how it plays out.
Yeah.
Yeah. Hey, Shruti,
Hi, Srini. Hi,
how are
Drishna.
you?
I'm good. How are you?
Good, good. So I I see that you've been going through the challenge lessons as well, but I don't know if you gave feedback to the lessons. Did you?
Yeah, I did.
You
I
did.
started
Okay.
giving that now. Yeah.
Okay. Cool. Cool. So how do you feel about that? The lessons. Is it good?
Yeah, they're good. They're very interesting and engaging. So I
Okay.
think I'm like behind by a couple of lessons, but
Okay.
I'll cover it in a few days.
Okay. Cool. Cool. That's good. So let's see. Well, I mean, I don't know if people are going to join. Maybe Uh, we'll stick around for a while. Questions? Do any of you have any questions or um, maybe feedback on maybe a certain thing could be done differently um, or explained differently, something like that? anything? Okay. So if there's nothing like that, then let me ask you a couple of questions. I kind of like didn't want to add a lot of images. Oh, no. So images are generally helpful. So I would prefer images than explanations. But since I'm sending it all through an email, there might be some deliverability issues and things like that. So I kind of refined that. I also added a little bit of ASCII-based images instead of like real images. In those places where ASCII images would not help, I would add an actual image. So the question is, are those ASCII images helping, or are they adding more to the confusion? Um, and do you think that adding like real images would be better, or like no change needed? Like just your thoughts on that.
Uh, like my perspective will be like I've never really thought about it because ASCII images are in itself doing their job.
Okay.
So, like if it is like this also, it is fine. And even if you
Okay.
are planning to like give real images, then that will be
Hmm.
also fine.
Okay. Okay.
Yeah, I think the ASCII ones are good, and you can even reduce the number of images.
Okay.
I mean, like, yeah, like a few things, it's like not needed if it's like extra work for you.
I see. Okay. Yeah, well, I mean, I think I'm I'm not a well, I'm not a creative in the sense that I'm not a person with a lot of aesthetic sense or anything like that. But I generally prefer a lot of images because it kind of explains a lot of things. So I would like to keep the images, but if the ASCII images are helping, I think that is good because it's primarily like the deliverability of emails actually gets affected a whole lot if you add a lot of images. That's kind of like the main deal. And I don't want people to like logging into an like a course website or something like that and reading the lessons because that's another level of complexity, right? You don't want them to be take like an additional step to get to it and then read it. That's not going to happen. So it's kind of like a conscious decision there. So okay, cool. Um,
Yeah, that is actually nice because some of the mail delivery system actually maps these emails with so many random pictures as spam.
yeah. That's the main thing, right? Like um I mean it's not in my control. It's basically like whatever if you're using Gmails, like whatever Google decides, the AI decides, and they could just put it in in the spam kind of setup. So that was kind of a conscious decision. But for some lessons, I do have like real images because I felt that it would be better and or can explain the concept better within real image. So yeah, we'll see. It's just one third of the way through. Uh, we have like two-third of the thing to cover yet. So cool. Okay, so what should we do today? Um, if there are questions, I can answer them. Maybe if not, I think I can also go through the slide deck for the AI stuff, but I don't know if this is going to be helpful or kind of like deviating from this challenge thing. What are your thoughts?
I have one question about the challenge.
Okay, go
So
ahead.
the patterns which you like told us to do
Mm-hmm.
with the car, like drive with the car, the
Mm-hmm.
eight and square and
Mm-hmm.
triangle. So I'm not able to like make the car go on the same track. It's like
Yeah,
it's forming a square like this, and then it's forming
yeah,
another
yeah.
square like
That's
in
okay.
different places.
Yeah,
Okay.
that's okay. So it's because you don't have position control here, right? You're just having this, um, you just have control over the velocity. Basically, you have control over the acceleration of the vehicle. That's all you have.
Yeah.
The throttle is acceleration, right? So, so that's okay. It's because it's going to be pretty hard to get the robot to a particular point. You could do
Yeah, I
something like,
tried
okay,
all combinations of like
yeah,
steering,
yeah,
throttle,
yeah. You could do something
velocity,
like,
everything, but yeah.
yeah. I think you can do something like, okay, get to the point, stop, and then get to the next point, but then you cannot turn in place. There is no in place turning, so you'll still have a curve. So,
Right.
yeah, it's basically to those exercises just to make you understand that, okay, this is hard. You
Okay.
cannot do that. Like in a real car, you cannot do that either, right? You cannot do like a
Yeah.
perfect square or a rectangle.
Yeah. Yeah.
Um, unless you have like a differential drive kind of a vehicle.
Right.
So that's kind of the idea. And when I initially wrote it up and I was trying to set it up, I tried to do it myself. I was like, okay, this is not working. And then I was like, yeah, this is good. This is a good exercise because then you'll see the deficiencies in that and that'll help.
Yeah.
So yeah, it's good.
Actually,
I'm,
the
I'm happy
solution
that you guys are trying it out. Sorry, Jishnu, what are you saying?
actually the solution wasn't working.
Sorry?
Actually, the solution itself wasn't working. I've tried
Yes.
like
Yeah, that's what I said, right? It's
Yeah,
kind of
even with your
impossible.
solution, it wasn't working. Yeah.
Yeah, it's kind of impossible. That's kind of the big main idea here. So, but if I say that in the lesson itself, people wouldn't even try, right? So that's why it's just like I left it hanging, give it a try, and then the next day when you look at the answers, like, okay, so this is what is possible, then you get the point.
Yeah.
Yeah. So I'm guessing that the solution in the next day is kind of helping here to kind of get
Yeah.
an idea. Okay, cool. Cool. Yeah. It's kind of like the whole kind of setup is an experimental thing. I just wanted to try out a lot of different ideas here. So the one part which I'm kind of missed in this challenge, but I'm trying to figure out how I can incorporate properly is the recall part. So basically, the best way you can learn is trying to recall and well, we have been used to if you want to retain some material in our head, the way we do it is we just reread it, right? That's how we have been trained to do it. But research says that that's not the best method. It's kind of one of the worst methods. The best way for something to stick in your head is you have to kind of go through the material again, but instead of rereading it, you have to try recalling it. So recall is the one which actually makes you remember more. And one trick there is to um, kind of like try to recall. If you say like, okay, recall the whole thing, we'll probably not recall anything. So we have to give the mind like some hints, but have like fill in the blanks kind of things, right? So uh, bring up the concept, but then have a few missing pieces there. Uh, Ironically, this is how all these LLMs are trained. The LLMs, like early on, when I mean now the training techniques have gotten so complicated, but early on, one of the major things was, okay, you have this whole knowledge or data from the internet. How do you train an LLM from that, right? So any machine learning system, you would train by you say that, okay, this is the question and this is the answer. That's how you generally start with, and that's your training set. And then you basically take something out of it and then say this is a validation set, and then another portion out of it and say this is a test set. So what you do is you go through the training set, you feed the input, you show the output to the model, and then you adjust the weights. That's essentially the back propagation of this whole machine learning thing. And then you use this validation set to see whether your learning is getting better or is getting worse. And then you finally use that held out test set to see whether you've learned or not. Um, so But if you have this whole data from the internet, how do you train? There is no question and answer kind of thing. So what they did was they said, okay, let's just take this thing as input, and then on the output side, we'll just mask out or remove certain parts of the input. And then let's just get the network training off that. Make it predict that missing pieces. Right? So there is no like a generic question or answer setup. It's more like, okay, can you expect like what would be the missing piece here if you have a part of the sentence or if you have this starting part of this thing? And that's how the training actually started. Um, or basically, the other way of looking at it is like that's how the machine learning system was improved to have a better recall or better way to fill in the things. And it's no surprise that our mind works the same way because the neural networks are kind of modeled out of our human brains, right? Um, so when I read about this is kind of intriguing to me. Anyway, I just went off on a different tangent, but so that's kind of the idea.
So are the LLMs modeled after the brain, or did we realize that recall is better after looking at LLMs?
Well, the LLMs are definitely modeled after our brains, right? Because it's all neural networks
Yeah.
in the back end. I mean, we use transformers now, but which is kind of a neural network, or it's kind of having the principles of a neural network. Um, the connection that I make here is basically it's just my own understanding. It's not something I read somewhere. It's just like, okay, I read about these
Yeah, it makes
memory and
sense.
recall, and then I read about this thing about this training thing. I was like, ah, that's interesting. It does have a way of kind of similarity between these two methods. So,
Yeah.
so what I was saying was, I still haven't figured out how to bring that into the lessons, like to make sure that we can have recalls. We can make the students recall what they have learned. And there's also this nuance to it is like there is a certain effect when if you recall every day versus recall after a few days versus recall after a week or a few weeks and things like that. So yeah, I don't know the dynamics of it completely yet, and I haven't figured out a way to incorporate that yet. Um, Having quizzes is one way to do it, and that's kind of a cliche because like, okay, it then becomes like a school or a college where you have some material and then you're going through some exam or so I don't know, I have to figure it out. So in graduate
So
school.
the questions which you send me at the end of every lesson, those help
Mhm.
me with
I see.
recall.
Okay.
So you can do that for this also.
Yeah, so I think maybe
It
if you
doesn't feel like a quiz because like the answers are right there, right?
right. Yeah.
So yeah,
Yeah.
I
So
cover the answers first and then read them later once I try to like get my own answers.
well, I mean, if maybe I could also move the answers to a next lesson so that
Yeah,
that
that
you
also
don't
works.
have them right away. The one downside with that is like when things are fresh in your head, if you don't get the answer right away, it's pretty hard to connect. Like if you get it after a day, it's pretty hard to connect to it, and kind of like the feedback loop that comes in immediately helps, right? So there's
Yeah.
a benefit to that. Yeah, I don't know. I'm still trying to figure it out. So in a graduate school, the way they are doing that is project-based courses, right? So in undergrad, you have a lot of these quiz-based courses, but then as you move to graduate school, it's more like project-based courses where you get to apply what you have learned, not exactly what you learned, but some way of like applying the ideas and formulating in your own head like how this would be applied.
Yeah.
So that's one way of doing it. So I'm trying to find a middle ground between these two. Um, we'll see. Maybe it's not like a generic solution. Probably it could depend on the lesson itself. Um, so so that's one piece I'm missing. But other than that, I think I'm happy with how the lessons are structured.
Yeah.
Cool.
Yeah, even the explanation is like pretty clear to me, like even
Okay.
the aesthetics and everything. That's why I told you like you don't need to put so many extra diagrams.
Oh, I see. Okay.
Yeah.
Yeah. Well, I guess that part is like you don't know like you'll not know like how which stage people are at. If a particular concept is familiar to you, then you would get it in just one explanation. But then someone might be completely new, and they might need that same topic being attacked from different angles to get the thing what they get to understand it. So that's kind of
Yeah.
the reason. So anyway, we'll see. We'll see. I think it's going good. So we'll see how it transpires for the next 2 weeks. Okay. So let's see. What else can we talk about? Anything else on the challenge itself? Okay, so the next thing I would like to ask is like, okay, this is kind of a speculative question. What would you like to do after this? Like, let's say if you want to have a continuation of this challenge, like after you're done with this challenge, I mean, you're still early on in the process, but what do you think would be useful for someone who's going through the challenge? I'd like to get your opinions on that.
Like currently, what I feel like is maybe I can relate these things to the nav2 stack,
Mm-hmm.
where actually autonomous navigation can be learned from the like what industry is using.
Mm,
So uh, I think that's where I can connect it
mm.
after
Okay.
going through it.
Okay, that's fair. So, yeah, so I did talk, so one of the main things I kind of like thought about when I started this was I thought like, okay, maybe in the end I can connect it all to nav2. But then I realized that okay, there's so much things to cover, and then if I bring nav2 into the picture, that's going to like uh, blow things up because it's kind of a beast in itself, right? So
Yeah.
so maybe we can, but I like your idea, and I kind of understand that it's kind of a logical progression. So um, I will think about it. So one thing about nav2 is you'll have to figure out a way to make it easy for people to kind of experience ROS2. Um, and you cannot expect everyone coming in to have a Linux system with ROS2 installed and set up. So it has to be something more like maybe having a VM set up already that they can play with, similar to the simulator, right? Um, Something like that. I haven't, I thought about it. I even like tried prototyping some things, but it was not, I mean, I couldn't come up with something simple enough. So
I'm not sure, but there can be Docker for
yeah,
nav2,
yeah,
right?
yeah. Well, yeah. So when I said a VM, I was thinking of Docker as well. But the thing with Docker is it is, I mean, you do have like built-in Docker ROS images, so we can actually do that. But then it won't be like getting a UI like out of Docker is a little complicated that most people might struggle with.
Yeah.
And then a VM, but the reason I was talking about a VM was like I thought about Docker first, and it's like, okay, this might be the easiest, but then you'll have to think about what kind of compute they have. Can they run this whole thing on their computer and still be able to get the UI out of it? And those things was kind of like was not straightforward. And then I also thought about, okay, what if we set up um, like a build farm kind of setup where they can run things remotely, and that would spawn like when they spawn off a computer on the cloud, and then run this Docker image and have things running there. But then the complexity, it's not just the complexity, the logistics associated with that, both from my end and from the people using that, would be much higher. So that's why it's like, okay, let's just do something really simple. Uh, but I'm really interested in setting up something that people can experience ROS. Um, so I'm actively thinking about it, like which is the best way to get ROS into the pipeline. It has to be lightweight and setup free, at least in the beginning. So it's kind of the challenge. So it's kind of funny that when you think about these things, you're like, oh yeah, this is like once you learn ROS or kind of like familiar with it, it's like, okay, this makes life a lot easier. I don't have to do a whole bunch of other things if I don't have ROS. Um, but then we kind of forget that initial learning curve in basically understanding system and setting up the system. That itself is a price. And for someone who is kind of learning the concepts, it would appear like a big deal. And someone who's like, for example, in this challenge, someone who's with us for like 21 days, it would be like kind of impossible. So I think if we're doing another challenge, maybe like um, getting them familiar with ROS2 or the NAV2 framework might be the might be the main goal of the challenge itself. But that's not uh, um, kind of something that is fancy enough that people would be interested in, right? So when I said self-driving car challenge, then that's something that's interesting, right? That's kind of the thing that would interest people. And essentially what we're doing is maybe like if you take a real self-driving car, this is I would say like maybe the code that we are writing here is maybe 1 or 2% of the whole self-driving car kind of setup, right? Um, but the principles do apply, right? Like maybe um, if you look at the whole operation, maybe 20 to 30% of what we do here is the overall principle of how this thing comes together. But on a real self-driving car, there's a whole lot of other things that goes into play to make it work. Um, so um, but when you say self-driving car and when you kind of deliver that principle idea, then that kind of attracts people. So I'm trying to figure out like you cannot just say, okay, come and learn ROS 2. That's not going to work. That's not fancy enough. So I have to figure out something like maybe some algorithmic thing or something that is kind of captivating for people to learn. Yeah, it's just my thoughts there. I don't know.
Yeah, I was actually thinking about that, like how we can manage the infra if so many people are there and everyone need to run the entire system on a cloud basis. That itself is
It's
huge.
painful, yeah. Yeah, and the other thing I mean, I think setting it up, it's kind of a trouble, but it's not too bad. I mean, I think right now there are like a lot of cloud services where you can spawn multiple, like you can spawn instances on demand, which can actually you can actually shut down after the use and all those things. Um, but there are challenges in the sense that it can get really costly at some point, right? With cloud services, if you're not careful, it could just like uh, eat away all your budget pretty quickly. So that's something I was kind of worried about, like people working with cloud-based computing early on, everyone does this mistake where they would leave their VM running and then and then see the charges
Yeah,
accumulating.
I used to
So,
see memes related to
but
this. I used to see memes related to this.
yeah,
Mainly, yes.
yeah, because it's kind of like pretty easy to kind of forget that. So I don't want people to get into that kind of situation. So yeah, so maybe we can have something like a um, not like a challenge, but maybe like a 1 day session or something like that, where people get to that session, spend the whole day, maybe like 4 to 6 hours working on the VM, and then the VM would be active during those time, and then we can shut it down after that. So that might be an option. I'm actively thinking on that, but I haven't come up with something that will work yet. So we'll see. Shruti, do you have any thoughts on what would be next? What should be next?
Oh, sorry, actually, I got disconnected in the middle, network
Oh,
issues.
that's okay.
So I was thinking you could do a drone challenge, but you just said you didn't want to do another challenge. So
No,
I'm
no,
not
I didn't
really
say
sure.
that. No, I didn't say that. In fact, I'm actually actively thinking
Oh,
on the drone side of things. That seems to be
oh,
interesting a
okay.
lot of people. At
Yeah.
least in my head, drone is kind of like is moved on from research to industry, because like just a couple of years ago, um, a lot of people at CMU was actually working on drones. We did have like a drone. We still have a drone cage with Vicon setup, like motion capture setup,
Mm.
where we track the drones and things like that. But the active research kind of it was there, and then it just moved on to industry, and now there isn't a lot of active research. So in my head, it's like, okay, drones that now that kind of thing is gone, but it's still active in a lot of people. It's still being used. The technology itself has not gotten old. So I
Yeah.
started thinking about it, and I was wondering, like, okay, what can we teach, and what are the things that would be interesting? The part I kind of realized is I don't want to teach people how to fly a drone. That's not what would be interesting. That would be like, okay, what do you need to do to become a drone pilot? Okay, that's out of the picture. That's not something I want to do. Then I could teach like how to build a drone, which is kind of a little interesting. Um, the problem with that is when you're building a drone, you actually don't understand all the mechanics behind it. So drone building has gotten to a point where it is mostly like a Lego kind of a setup where you get this motor, you get this flight controller, you get this motor control board, you slap them all in, you go to Betaflight, you configure it, and it just flies. That's how modularized drone building has become. So if you actually if I teach that, then people would learn how to build a drone, but don't know much about like what's going on behind the scenes, like what's actually happening inside. Um, and
Right.
that would be useful for drone pilots. Like if you're having a drone business, then sure, just learning how to build a drone would be useful. So I said, okay, that is also not too interesting for me. So what would be actually interesting? So the part that would be interesting is like trying to teach how the drone actually operates, like what makes it run, right? Um, so one part of it is the state estimation, like figuring out the orientation of the drone, and that is kind of like the most crucial part in this whole process because if your drone okay, if you're just having controls for all the four motors, let's say you have joysticks and you can just fiddle with the throttle for all the four motors, do you think you can control the drone to fly stably? Just a question. What do you think?
No, it will be wobbling around.
But do you think you can fly it? Like, yeah, wobbling is fine. Yeah, you'll be manually
Uh, like uh, we might need very like what do you say? It will be very difficult if onboard
Mhm.
computers are not actually taking care of it.
Yeah, actually, it's going to be impossible. That's kind of the reality. I'll tell why. So what happens is you're constantly evaluating your orientation, basically the roll and pitch of your drone, and this is being evaluated at a very fast rate. I mean, you know that the state estimation is happening maybe like 100 times every second or something like that. Um, so And then there is these micro adjustments that happens to the throttle of the motors that kind of keeps it stable. And if you're doing it visually, in the sense that when you're flying the drone, like if you have throttle for all the 4 motors and you're visually doing it, uh, it is kind of impossible, because you would look at the like the drone maybe taking off, and then you'd see like, okay, this side is dipping. So you visually see that, and then you have to respond by pressing the throttle on that one to kind of come up, right? So that lag in basically visually seeing, even if you're like really practiced and you know all the things like subconsciously, and your fingers would control all the throttle subconsciously, it is still too much of a lag for you to control the drone. So what happens is, like, by the time you kind of give throttle to this motor has dipped so much that this one is kind of like going too far. And then when you give throttle to that, you have to compensate too much. And then when the compensation comes in, it kind of like goes too bad. So what happens is, like, it's not just like too much oscillation. You cannot control it. It just flips even before you can control it, it just flips back. So that's how fast the responses need to be on a drone, and that's what the flight controller takes care of. So the reason I was talking about this is because that part is the actual interesting part in a drone, right? And then the next part is like, when we want to do autonomy or autonomous operations with the drone, what would you do to kind of like bridge these two? So if you know how this drone operates internally, then the autonomous operation, you can you can actually go in and hack. If you can hack in this algorithm, you can get even finer control on what are the autonomy things you can do. But if all you have is just a black box saying that, okay, my drone can fly up or down or go forward or back, then there is only so much you can do, right? So that's kind of the idea with. So I was thinking like, okay, so maybe if I can teach people like how the state estimation happens, like about this control loop, and what really happens internally, and then how it links to autonomy, maybe that will be useful. So again, it's a long answer to the idea that Shruti was talking about the drone challenge, right? So I do have that in my head, and I'm kind of working towards that, but it's still early on in the process. But I think I know what I want to teach that would be actually useful. So yeah, so there'll be another challenge soon, but it's going to take me some time. So the part with the state estimation, like estimating the angles, the roll and pitch, that involves a little bit of complex math. So what you're trying to do is, like, we are going to take the gyro measurements from the IMU, and then integrate that to so the gyro gives the angular rates. So we'll have to um, differentiate that to get the angles. And then that's what we will use to integrate, to kind of like put together to basically build a filter that would estimate the angles. So it's kind of like involves a little bit of Kalman filter and math with this differentiation, and then the math with the getting the angular rate. So the challenge there is like figuring a way to actually make it simple enough that anyone can understand that. I think that's the main challenge here. So I'm kind of like working on that. If I can accomplish that, then that'll be really a huge win, because a lot of people start with, say, state estimation and kind of give up on that particular part of the math. Like, okay, it gets too complicated there. So if you can make it simple enough, then that'll be a huge win. I'll keep you guys posted on that. Have you guys built any drones before? Any experience with that?
Not really.
Okay. Are you guys interested in drones?
Yeah, actually, very much.
Okay, cool. Yeah. So there are a lot of, I mean, I have a lot of these motors that I got from like these online things. you can actually put them together to build a drone. I also have these flight controllers that I got. I also have a couple of drones that pre-built drones that I got. Um, what I was more interested early on was the fixed wing flights, these aeroplanes. Are you guys familiar with that? There's a lot of model aeroplane kind of
Oh, okay. Yeah.
hobbyist thing, right? So I was getting these drone motors and I was trying to use those to build model airplanes. And that's kind of like a really interesting area. Um, and you can actually control it manually. Like you don't have to have like a flight controller in there to control this thing, but it'll be more like a piloting skill. So like I'm more of a builder than a pilot. So all the builds I made actually crashed uh, quite badly, but I have like a couple of footages of me flying the fixed winged aircraft to certain like maybe a minute or so without crashing. It was fun. So building them is also it's also fun because it's just like okay, the aerodynamics of the wing. I mean, there are a lot of tutorials and videos online. You don't have to build everything from scratch. Um, but I've built like a flight and then put in a motor to it and then a motor controller to it and you have like a joystick where you can control it and yeah, it's a lot of fun. Again, sorry. This is kind of like a way tangential to what we're talking about, but yeah. Like building something that flies is kind of like a something that I think inspires or uh, intrigues the curiosity of a lot of people. So,
Yeah, actually, I was behind helicopters
oh,
for some time.
nice.
Yeah,
Have you built one?
yeah, not actually, but
Okay.
I really love how those mechanics work, the swash plate and things. That's,
Yeah, yeah. Yeah, I like when I was a kid, I was thinking that, oh yeah, maybe they'll just control the throttle of the wings to kind of like go up or down. And when I learned that they would adjust the angle of the blade
yeah,
to decide how it goes up or down or forward or back, I was like, wow, that is really interesting. And the part that really kind of caught my attention was like this thing is running this like it's spinning this fast and they can control the angle of the wing like that was like mind blowing to me.
yeah, exactly.
So the mechanics
That
there's the
engineering that they have put in, it's mind blowing.
yeah the amount of force that is needed to adjust the angle of the wing when it's spinning that fast and yeah, so the mechanics of helicopter is definitely kind of interesting. So well, I
So
guess
the angle of the wing is used to change the direction.
yeah, yeah. So basically, the helicopter has these four kind of four blades, right?
Yeah,
And
yeah.
it spins at a constant rate. And what
Okay.
really what makes them go up or down is setting the angle of the wing. So if the wing is perfectly flat, there is no lift.
Yeah.
So the thing would just stay
Oh,
where
okay,
it is.
okay.
And then
Oh,
if
nice,
you
nice. Makes sense. Okay.
increase the angle of instance, then you would push more air
Right.
down, and then so that would give you more lift. So to go
Okay.
down, you would just adjust it so that it's not you're not put
Oh, nice.
so
Okay.
that's kind of one the main kind of control on a helicopter to do this thing.
Okay.
And about the forward and backward, what do they do with that? Is that the wings or
It's actually they are controlling the angle of attack of the individual, like
I see. Okay.
individual blades at particular positions.
That's it. Okay, cool. So basically, you would so if you change the angle of attack for all the wings, then you're just going up or down. But then if you set it up so that one of the wing there is a little bit of downforce on this side. When wing comes here,
okay,
you'd
okay.
have the downforce this side. Then you're kind of pitching down, but then you also have the lift, so you kind of like go in that direction. So
Oh,
it's
that's really interesting.
yeah.
Yeah.
Yeah,
So
actually, you can get these YouTube videos where they explain
Okay.
these things with visuals, so it will be
Yeah.
more intuitive.
yeah.
Oh, okay.
So the one thing that I kind of like learned when I actually was trying to do this helicopter thing was the wings is like basically to give you stability. If not, there is nothing stopping the helicopter base from rotating when the wing is rotating. That's another interesting concept, right? So you have the helicopter, you have the wings,
Mhm.
and you're using a motor to rotate it. And we see the way the base kind of like stable, so we assume that yeah, it should be stable. Like why not? But then if you just take a motor, if you attach to the ground, then the motor would be stable and the wings, the blades would spin. But if it's not attached to anything, then there is nothing stopping the motor base itself rotating, right? So when you have like the wings rotating, the base would also rotate in the opposite direction, right? So when I was like I playing with things, I was like, okay, this is interesting, and this is the reason why they have a kind of a wing rotor, which is basically just resisting the base from rotating in any direction. It just and that's why the axis is also different. It's just spinning here so that it doesn't move in a particular direction, or it's resisting the move in a particular direction. Yeah. So the physics of it is kind of like really intriguing and interesting. Anyway, this is I think we started off in the challenge and went to drone and fixing and into helicopters. That's kind of way into the other side, but I mean I enjoy these kind of discussions. I get intrigued.
Yeah, actually, I've got this very like I'm crazy about things that fly. So the discussion is really nice.
Oh, cool. I'm happy you enjoyed it. Cool. So, are there anything else before we wrap up? Okay, I guess not. So yeah, well, just continue the challenge. We'll see how it goes. I still have this slide deck for for AI tools, but I was not. I'm kind of like holding it off because I don't want people to get derailed from the challenge part of things. So let's just get back to this after the 2 weeks. Okay.
Yeah, sounds good.
Okay. And I guess we can end this call early. I'll talk to you guys next week. Okay, cool. Shruti, I'll call you back in like 5 minutes.
Yeah, sure. Okay.
See you guys. Bye.
Bye bye.
Mhm.